Shikdar. I welcome you all on behalf of Academy of Earth Sciences. As you know, recently the Assistant Hydrogeologist exam was conducted on 2nd of April 2023. Today this video consists of the solution of question number 31 to 60. Okay, let's start. We have is question number 31. क्या है? A normal graded bed of sandstone is noticed with fluid cast at its base and internally made up of massive plain laminated and ripple laminated subdivisions in order of superposition. The sandstone bed is interpreted to be the product of debris flow, grain flow, turbidity current या फिर contour currents. देखिए, in the case of the structures that are given is the fluid cast, plain laminated, ripple laminated subdivisions and a normal graded sandstone. अब क्या है? Order of superposition में क्या है? We have a normal graded sandstone, that is the coarser sediments are at the bottom and it finer is upward, fining upward. Okay, normal grading, fining upward. Then what we have is the plain laminated bed, then the ripple laminated bed. Okay, and this is in the order of superposition, and the fluid casts that are present at the base of the normal graded sandstone. Now, in the case of the fluid cast, as you can see here, we have the picture of the fluid cast. These fluid casts are formed when the water that flows near the sediment, it plunges onto the sediment surface and it forms a vortex due to which the former part of the sediment is eroded. That is, the sediment is eroded at the upstream side and it forms a bulbous part at the upstream side due to the erosion and it pinches at the downstream sides. So what structure we get is this type of structure. Okay, this is a fluid cast with a bulbous upstream part and a pinching downstream part. This is a fluid cast, and in the case of the fluid casts are a characteristic feature of turbidity current. ठीक है, अब और क्या है कि हम लोगों को क्या मिला है? A normal graded bed, then we have a plain laminated bed and then the ripple laminated bed in sequence of superposition. यहाँ पे जो पिक्चर दिखाया गया है वो क्या है? बाउमर सीक्वेंस का. ये जो बाउमर सीक्वेंस है ये भी फॉर्म होता है टर्बिडिटी करंट के वजह से, एंड इन द केस ऑफ द बाउमर सीक्वेंस द डिफरेंट layers that we have is a massive or a graded sandstone bed with a top parallel laminae, plain parallel laminae overlain by a ripple, wavy or convoluted laminae overlain by a upper parallel laminae. तो यहाँ पे हम लोग देख सकते हैं कि जो ऑर्डर ऑफ सुपरपोजिशन दिया गया है इट इज फुलफिल्ड बाय द बाउमर सीक्वेंस एंड ऑल्सो दैट द फ्लूइड कास्ट इट ऑकर एट द बेस ऑफ द मैसिव ग्रेडेड बेड. ठीक है, now here we can see that all these given statement it is fulfilled by the turbidity current. So the answer will be turbidity current. अदर ऑप्शंस भी देख लेते हैं. इन द केस ऑफ डेब्री फ्लो, डेब्री फ्लो क्या होता है? जनरली इन द केस ऑफ व्हेन द सेडिमेंट कंसिस्ट ऑफ लार्जर क्लास, दीज लार्जर क्लास दे आर सपोर्टेड बाय अ मडी वाटर मिक्सचर which is cohesive in nature. Okay, the cohesive force is generated by the muddy water mixture which supports this clast, and the flow that is formed is called a debris flow. It is a sediment gravity flow. The debris flow are internally structureless. वो अंदर से उनका they are structureless and they shows pore sorting. Okay, different types of grain size are found. This shows pore sorting. So debris flow में fluid cast भी नहीं मिलता, so ये आंसर नहीं होगा. Okay, grain flow क्या है? When the sediment consists of granular particles, these particles they as they move downhill they collide with each other, and due to this collision a dispersive force is generated, and due to this dispersive force, that is the grains they collide and they move apart. This is the dispersive force that is generated, and due to this generated dispersive force the grains start moving, okay, downhill under the action of gravity. This is a type of sediment gravity flow where the grains are supported by the dispersive force due to grain collision. This is called the grain flow, and in case of grain flow, fluid cast is not found. Okay, so grain flow could not be an answer. Another, we have the contour current. What are contour currents? Contour currents are the undercurrents. They are the undercurrents. Generally अगर हम माने कि these are the oceanic part, the undercurrents that flow along the western margin of the ocean basins, and these, due to the flow of these currents, the surface water, they mixes with the nutrient rich cold deeper water. Okay, they are known as the contour currents. Okay, and these contour currents generally form a structure which is known as contourites. So fluid cast not found within the contour currents. So in this case contour currents भी आंसर नहीं होंगे. Okay, fluid cast जो erosional फीचर मिल रहा है, ये जनरली टर्बिडिटी करंट्स में ही मिलते हैं, एंड ऑल दी सुपरइम्पोज स्ट्रक्चर्स दे आर आल्सो फाउंड विद इन द बाउमा सीक्वेंस दैट इज डेवलप्ड बाय द टर्बिडिटी करंट. ओके, so the answer will be C for question number 31. Okay, the next question is question number 32. 32 देखिए क्या दिया है कि in carbonate diagenesis, if calcite cement is overgrown on a single calcite crystal in same optical orientation, it is referred to as rim overgrowth, antitaxial overgrowth, blocky overgrowth या syntaxial overgrowth. Options देखिए. rim overgrowth क्या होता है? जब कोई central crystal के according एक रिम ऑफ ग्रैन्युलर एग्रीगेट जो ग्रो करता है. ओके, दीज ग्रैन्युलर एग्रीगेट्स दे हैव ग्रोन अराउंड द सेंट्रल क्रिस्टल्स. दीज ग्रेन्स ऑफ द सीमेंट they do not have any optical continuity with the crystal. They are called as rim overgrowth. In the case of blocky overgrowth क्या होता है? Generally when the central crystal is covered by a cement in which the grains are generally having a blocky nature, okay, and they are haphazardly present around the central crystal, they are called as a blocky overgrowth. Now as the grains of the cement, they are blocky and haphazardly oriented, they do not have any optical continuity with the central crystal, so they are called as a blocky overgrowth. Now syntaxial overgrowth क्या होता है? When the cement that grows around a central crystal, it has an ऑप्टिकल कंटिन्यूटी. मतलब ये क्या है? ये जो सीमेंट ग्रोथ है ये ऑप्टिकल कंटिन्यूटी है विद द सेंट्रल क्रिस्टल. इट हैज़ एन ऑप्टिकल कंटिन्यूटी विद द सेंट्रल क्रिस्टल. दिस इज द सेंट्रल क्रिस्टल एंड दिस is the cement layers. Okay, these layers are in optical continuity with the crystal. Then it is known as a syntaxial overgrowth. अब syntaxial overgrowth के opposite का क्या होता है? Antitaxial overgrowth. Now in the case of antitaxial overgrowth, as the term suggests, it do not have any optical continuity, means the cement and the calcite crystal do not have any optical continuity in antitaxial overgrowth. तो हम क्या देख रहे हैं? rim overgrowth, antitaxial और blocky overgrowth में there is no optical continuity between the calcite crystal and the calcite cement. So ये तीन आंसर नहीं होंगे. But syntaxial overgrowth, yes, there is an optical continuity, so this will be the answer for question number 32. Okay, answer D. Question number 33 देखिए. A carbonate rock that contains almost no mud and shows grain supported framework is named as grainstone, packstone, floatstone, bendstone. Okay, अब क्या है? कार्बोनेट रॉक के लिए हमें एक क्लासिफिकेशन दिया गया है which we know as the Dunham classification. In the case of Dunham classification, it is mainly based on texture. Here we have different terms like the mudstone, wackestone, packstone, grainstone, floatstone, rudstone, bafflestone, bendstone and framestone, depending upon different parameters. Now, what is a grainstone? A grainstone, as you can see here, it consists of no lime mud and is grain supported. It has no mud and it is grain supported. Okay. In the case of packstone देखिए, it consists lime mud and is grain supported. फिर packstone क्या है? It consists of lime mud and is grain supported. Float stone क्या है? It is matrix supported. The float stone, it is matrix supported. Okay. And in the case of bindstone देखिए, in the case of bindstone, here the organisms they encrust and bind the original component. Here the autochthonous limestone original components organically bound during deposition, and here the binding factors are the organisms. Okay, they are called as the bindstone. मतलब they are the original components bound together. Okay, they are neither grain supported nor matrix supported. Now in the question it is given a carbonate rock that contains no mud and is grain supported. What we have here is no mud and grain supported is grain stone. Okay, पैक स्टोन नहीं होगा, मड है. फ्लोट स्टोन तो ग्रेन सपोर्टेड नहीं है, मैट्रिक्स सपोर्टेड है. एंड बाइंड स्टोन तो ना ही ग्रेन है ना ही मैट्रिक्स. दे कंसिस्ट ऑफ द ओरिजिनल कंपोनेंट बाउंड टुगेदर बाय द organisms. Okay, so for 33 the answer is A. 34 क्वेश्चन नंबर 34 में क्या दिया हुआ है? इन अ बेरोवियन जोन ऑफ मेटामॉर्फिज्म प्रेजेंस ऑफ बायटाइट, क्लोराइट, फेंजाइटिक, मस्कोवाइट, क्वार्ट्ज, एल्बाइट असेंबलेज मार्क्स द एल्बाइट जोन, बायटाइट जोन, जियोलाइट जोन या फिर क्लोराइट जोन. अब देखिए इन द केस ऑफ द बेरोवियन जोन हमें कहाँ पे मिलता है? जनरली वी फाइंड द बेरोवियन जोन इन द केस ऑफ regional orogenic metamorphic terrains. Okay, here we have different zones, that is namely the chlorite, biotite, garnet, staurolite, kyanite and the sillimanite. These are the zones within the Peruvian metamorphic terrain. Okay, now as you can see in question option 1 albite zone तो Peruvian zones में है ही नहीं. Okay, तो फिर ये तो आंसर होगा नहीं. एंड द जियोलाइट जोन भी यहाँ पे नहीं है तो ये भी नहीं होगा. वी हैव द क्लोराइट जोन एंड द बायटाइट जोन, कोई एक होगा. नाउ इन द केस ऑफ द क्लोराइट जोन जनरली द मिनरल assemblage that we have is chlorite, muscovite, quartz and albite. Okay, chlorite, muscovite, quartz and albite. In the biotite zone we have biotite, chlorite, muscovite, quartz and albite. Okay, these are the mineral assemblage of biotite zone. So in the question it is given that the mineral assemblage is biotite, chlorite, fengitic, muscovite, quartz and albite. What is the answer will be then? It will be biotite zone. chlorite zone में biotite होता नहीं है, so answer ना होगा B, 34 का B. Okay, see we have the question number 35. Question number 35 में क्या है? Which one of the following is a characteristic assemblage of the granulite faces metamorphism of mafic rock? Granulite faces metamorphism of mafic rock में कौन सा mineral assemblage होता है? Now you see which we have is hornblende, plagioclase, quartz, garnet. Option A. Fosterite, orthopyroxene, clinopyroxene, epidote. Option B. Clinopyroxene, orthopyroxene, plagioclase, garnet, quartz. Option C. And fosterite, orthopyroxene, clinopyroxene and staurolite in option D. देखिए in the case of the granulite faces, हाँ granulite faces में जो भी mineral occur करता है वो dehydrated होते हैं. Okay, dehydrated mineral assemblages मिलते हैं. Why? Because granulite faces represents a high temperature condition where the hydrous mineral assemblages they are dehydrated. Now here as we can see in option A, hornblende which is a hydrous mineral, so hornblende cannot be present in the granulite faces. Okay, it is not the answer then. In the case of fosterite, second option fosterite generally are present at the contact metamorphic aureoles. They are formed due to contact metamorphism. Okay, fosterite फिर granulite faces में they are not present. Okay, so B is not an answer. Again fosterite we can see it is in D. D भी आंसर नहीं होगा क्योंकि fosterite तो contact metamorphic terrains में होते हैं. In that case what is the answer? That is C. Clinopyroxene, orthopyroxene, plagioclase, garnet and quartz. This is the mineral assemblage that we find within the granulite faces of mafic rock. Okay. Question number 36 में क्या है? When flattening occurs in rocks that contain rigid grains, zones of relatively low pressure develop on the sides of the crystals that are normal to the maximum compressive stress. These zones are called solution cleavage, pressure shadows, pressure solutions or stylolites. देखिए, in the case of the pressure solution cleavage, what is solution cleavage? Generally, they are the when within the rock there are many disjunctive cleavages, okay, that develop due to pressure solution. These are the disjunctive cleavage, okay, that develop due to pressure solution. And these rocks are mainly the quartzites and limestone, the limestone and quartzites, okay. Due to pressure solution, these disjunctive cleavages, they develop in these rocks that mainly consist of resistant minerals, okay. These minerals do not break up easily, they are resistant in nature, and these rocks, they generally show disjunctive cleavage. They are known as the solution cleavage. What is pressure shadow? Pressure shadow क्या होता है? Pressure shadow generally we find in the case of regional metamorphism, where the porphyroblasts, which are oriented along sigma 1 direction, these porphyroblasts, they are called as the, okay, they are under high pressure, due to which the matrix that surrounds these porphyroblasts, they get partially dissolved and they get redeposited on either sides of the porphyroblasts along the zones of low pressure. यहाँ पे क्या है? low pressure है. यहाँ पे ये deposit होने की वजह से यहाँ पे we get the deposition. So these are the low pressure zones and they are known as the shadow zones. And this structure is called a pressure shadow. Okay, this is called a pressure shadow. Okay, pressure solution क्या होता है? Generally when the grains are in contact, they initially remain in a linear contact, but with increasing pressure, okay, with increasing pressure, the grain contact, it becomes a zigzag in nature, okay, and this occurs due to pressure solution, where due to excessive pressure the particles near the contact, they get dissolved, and the grain contact from a linear contact, it become a zigzag or a curvy contact, okay. This is called a pressure solution. And another feature of pressure solution is that with continued grain contact being zigzag, these that develops due to the pressure solution, okay, these are known as the stylolites, and they generally form at a deep burial condition, okay. They generally form at a deep burial condition, these stylolites. Now what we have is in the case of the pressure solution cleavage, their disjunctive cleavage, there is no such rigid grains along which there is a deposition of the matrix mineral, okay, on either side of which there is deposition. So solution cleavage आंसर नहीं होगा. प्रेशर शैडो क्या है? यहाँ पे पोरफायरोक्लास्ट के दोनों साइड में the matrix mineral, they get dissolved from high pressure region and redeposited at the low pressure shadow regions. They are known as the pressure shadow, and these porphyroclasts, they are oriented normal to the maximum compressive stress direction. So here we can see that these zones are called as pressure shadows. Now pressure solution क्या होता है? प्रेशर सोल्यूशन जनरली ग्रेन टू ग्रेन कॉन्टैक्ट में होता है, जहाँ पे लीनियर कॉन्टैक्ट ड्यू टू द प्रेशर सोल्यूशन इट बिकम्स अ कर्वी और अ जिगजैग कॉन्टैक्ट, ओके. प्रेशर सोल्यूशन नहीं होगा. स्टाइलोलाइट्स व्हेन अ जिगजैग ग्रेन कॉन्टैक्ट दैट ऑकर्स ड्यू टू प्रेशर सोल्यूशन, okay. So stylolites is not the answer for the given statement, okay. So the answer will be pressure solution, option B, for question number 36. Now what you see is the question number 37. It is given that match list 1 with list 2 and select the correct answer using the code given below. the list. List 1 consists of rock name and list 2 the description. Rock names are blue schist, pseudotachelite, hornfels and skarn. अब क्या है देखिए, blue schist क्या होता है? Blue, why? Because presence of sodic, that is Na rich blue colored amphibole, okay, and it is a cystose rock. इसमें सिस्टोसिटी होता है, that is why it is called a blue schist. Pseudotachelite क्या होता है? Pseudotachelite, they are generally formed at excessive high pressure region where the friction is very high. Due to frictional force, the generally glassy texture develops at the frictional grain contact, and here the grains are finer in nature, okay, they are very fine in nature, the grains are very fine, and here generally these pseudotachelites, they develop within veins. Now what we have, the third is hornfels. Hornfels क्या होता है? Hornfels are the non-cystose rocks and they are very fine grained, okay, and they are mainly formed due to contact metamorphism, due to which there is recrystallization that occurs within the minerals in the case of hornfels. Another thing is that hornfels are rich in silicates and oxides, okay. Hornfels, they are rich in silicates and oxides. Now the third is hornfels and fourth we have skarn. जनरली स्कार्न क्या होता है? स्कार्न भी कॉन्टैक्ट मेटामॉर्फिज्म या फिर मेटासोमैटिज्म के वजह से फॉर्म होता है, and they are rich in Ca, Mg, Fe, Mn, okay, सिलिकेट्स, ये होता है स्कार्न. चलिए ऑप्शंस देखते हैं क्या है. डिस्क्रिप्शन में वेरी वी हैव अल्ट्राफाइन ग्रेन्ड vitreous looking material occurring as thin veins, okay. Sodium rich amphibole containing cystose rock, a non-cystose very fine grained rock mainly composed of silicates plus minus oxide minerals with substantial recrystallization, a metasomatic Ca, Fe, Mg, Mn silicate rock with compositional zones and bands. Now blue schist, that is sodic blue amphibole and cystosity present, so option 2 is for blue schist, that is Na rich amphibole with cystose rock. Pseudotachelite, option 1, because they are ultra fine grained and vitreous looking material occurring as the veins. You can see this. Hornfels, they are a non-cystose very fine grained rock mainly composed of silicates plus minus oxides with substantial recrystallization. C is 3 and the remaining D is 4. So option is A2, B1, C3, D4, where option B is for 37. Option B is correct, okay. Question number 38. Presence of calcite, dolomite, quartz, diopside, wollastonite, K feldspar, forsterite in a regionally metamorphosed rock under granulite phases suggest which one of the following type of protolith? Mafic, पेलिटिक, कार्बोनेट या फिर अल्ट्रामैफिक प्रोटोलिथ होगा. अब मिनरल असेंबलेज क्या है? कैल्साइट, डोलोमाइट, क्वार्ट्ज, डायप्साइट, वोलास्टोनाइट, के फेल्सपर एंड फॉस्फराइट आर द मिनरल असेंबलेजेस. कैल्साइट का फॉर्मूला क्या है? CaCO3, ओके. डोलोमाइट CaMg, CO3 whole 2, quartz SiO2. Then what we have is diopside. Then we have is wollastonite, K feldspar, and we have the forsterite, that is. So from here we can see that the elemental composition is CaMg, KAlSiO2. Okay, it is rich in CaMg, potassium, aluminium, silicon, oxygen and carbon dioxide. Okay, so in the case of the mafic protolith, they are generally rich in MgFe. Okay, they are generally rich in MgFe. Okay, so मैफिक प्रोटोलिथ तो होगा नहीं, क्योंकि इन द केस ऑफ द मैफिक प्रोटोलिथ, क्योंकि ये MgFe और Ca में रिच है, Fe जो एलिमेंट है ये हमें नहीं मिल रहे हैं इन मिनरल्स में, सो मैफिक प्रोटोलिथ इज नॉट एन आंसर. पेलिटिक में क्या होता है, ये क्या होता, पोटेशियम, सिलिकॉन एंड एल्यूमिनियम रिच होता है. वी हैव पोटेशियम, सिलिकॉन एंड एल्यूमिनियम, बट वी डू नॉट हैव कार्बन डाइऑक्साइड in the case of pelitic protolith. Okay, so this is not the answer. In case of carbonate rock, the carbonate rocks, they are generally rich in Ca, Mg and CO2. Okay, so we have Ca, Mg, CO2. So carbonate rock can be the answer. In the case of ultramafic, they are rich in Mg, Fe, nickel and chromium. So Fe component है नहीं, निकेल भी नहीं है, क्रोमियम भी नहीं है within these mineral assemblages that is given. So ultramafic could not be the answer. So the answer is carbonate rock acts as a protolith for these mineral assemblages. Okay. Now option C is correct for question number 38. In question number 39. 39 में we have the formula 3 anorthite giving grossular, 2 kyanite and quartz is a reaction which makes the eclogite phases in metabasic rocks. What will be the composition of grossular in the reaction given below? Ca3Al2Si3O12 or CaSiO3 or CaMgSi2O6 or CaCO3. Okay, now see the reaction. क्या होगा? Here it is 3 anorthite giving grossular, 2 kyanite and quartz. So the formula is Ca(Al2Si2O8). ग्रॉसुलर हम जानते नहीं हैं, निकालना पड़ेगा कायनाइट का, Al2Si(O5) and quartz Si(O2). Now multiply each of the element with 3. So we have Ca3, Al6, Si3 2 is 6 and O8 3 is 24. Now grossular, keep it in hand, we don't know. अब कायनाइट का क्या होगा? Al4 Si2 O10, okay, and SiO2. Now see, we have on the left hand side this part, and on the right hand side, after adding these two, we will have, that is Al4 Si3 O12. okay, अब लेफ्ट हैंड साइड और राइट हैंड साइड माइनस कर दें, then what will we have is Ca3 Al6 minus 4 2, Si6 minus 3 is 3 and O24 minus 12 is O12. So the answer is Ca3 Al2 Si3 O12, which is option A for 39. Option A is correct. Okay, number 40. Given that granoplastic polygonal texture is an example of texture of recrystallization, texture of crystallization, metasomatism या फिर myelonitization. Now we know that in the case of granoplastic polygonal texture, a main feature of this is that the grains that are present are first monomineralic, okay, means like quartzite, the rock is monomineralic in nature, and here the grain boundary is a triple junction where the grains meet at equivalent to 120 degree. Now see in the figure, what we have is this grain is meeting with the other two grain at a triple junction. Okay, generally this feature is present in the case of recrystallization texture, and also monomineralic means these are the quartz grains. Okay, this is also a property of a recrystallization texture. So in the case of the granoplastic polygonal texture, it is due to the texture of recrystallization. Okay, द आंसर ए इज करेक्ट। ग्रैनोप्लास्टिक पॉलीगोनल टेक्सचर कभी क्रिस्टलाइजेशन या फिर कॉन्टैक्ट मेटामॉर्फिज्म या फिर माइलोनिटाइजेशन इस प्रोसेस से नहीं होता। इट इज ड्यू टू स्टैटिक रिक्रिस्टलाइजेशन दैट द ग्रेन्स दे मीट एट a triple junction 120 degree, okay, because they are monomineralic in nature. So option A is correct for question number 40. Next, question number 41. In metamorphism of calc-silicate rocks, which assemblage can be considered equivalent to the sillimanite zone of pelitic rock? Okay, for the calc-silicate rock, which mineral assemblage is equivalent to the pelitic rock? Okay, now see, in the case of the calc-silicate rock, the mineral assemblages that we have is anorthite, diopside, garnet. It is equivalent to the sillimanite zone of pelitic rock. Then we have is chlorite, biotite, garnet, and this is equivalent to the chlorite, biotite, garnet zone of pelitic rock. And next what we have is the anorthite, hornblende, garnet. Okay, this mineral assemblage of the calc-silicate rock, it is equivalent to the staurolite kyanite zone. Staurolite kyanite zone के equivalent होते हैं। तो in the question कहाँ पे है कि which calc-silicate rock mineral assemblage is considered equivalent to the sillimanite zone? Here we can see that sillimanite zone of pelitic rock is equivalent to the anorthite, diopside, garnet mineral assemblages of the calc-silicate rock. Option anorthite, pyroxene, pyroxene means diopside, joacite, calcite, biotite, joacite, hornblende, anorthite, hornblende. So in this case, joacite, calcite, biotite या फिर joacite, hornblende, we cannot find these assemblages in the given series. नहीं होगा ये option. Anorthite, hornblende, we can find it here. Anorthite, hornblende, it is representing staurolite to kyanite zone of the pelitic rock, not representing the sillimanite zone. Not answer. And therefore, anorthite diopside, what we can see here is anorthite diopside, it is equivalent to the sillimanite zone of pelitic rock. So this mineral assemblage, it represents the sillimanite zone. Answer A is correct for question number 41. Question number 42. 42 में क्या दिया हुआ है? The hinge line of a fold is a line that divides the fold into two symmetrical part. A line that is always parallel to fold axis. A line of maximum curvature in a folded bed. A line of minimum curvature in a folded bed. Okay. Now see, what is a hinge line? Hinge line is the line that joins the point of maximum curvature. That joins the point of maximum curvature in a folded bed. ये क्या है? ये line जो है, ये hinge line है. Okay. Now you can see in this figure that this part is a cylindrical fold. By cylindrical fold we mean that the hinge line is parallel to the fold axis in the case of cylindrical fold. Okay, now in the case of the non-cylindrical fold, the criteria is that here the hinge line is curved and it is not parallel to the fold axis. यहाँ पे hinge line fold axis के parallel नहीं होता in the case of non-cylindrical fold. So in the given option, a line that divides the fold into symmetrical part. देखिए, पहली बात तो ये है कि symmetrical part में कभी एक line कभी कोई folded structure को divide नहीं करेगा. It could be a plane that could divide a fold into two part, not a line. Okay, so option 1 नहीं होगा. Option 2, a line that is always parallel to the fold axis means hinge line is parallel to the fold axis only in case of cylindrical fold. Always parallel नहीं होता. Option B नहीं होगा. A line of maximum curvature in a folded bed. Yes, a hinge line is the point that is a line that joins the point of maximum curvature in a folded bed. Okay, option C correct है. A line of minimum curvature in a folded bed. नहीं. When the line it is representing the maximum curvature, it could not represent the minimum curvature. So option D is not correct. So for 42, option C is correct. Is 43. It is given that in ocean, regional strike-slip faults associated with lithospheric plate boundaries are known as transform fault, tear fault, ridge fault, Caesar fault. देखिए, in the case of a transform fault, it is a regional scale strike-slip fault, okay, and it is associated with plate boundaries. Okay, now in the case of the tear fault and ridge fault, देखिए ये जो दो fault है ये भी strike slip fault है, they are also strike slip fault, but in the case they are occurring at a localized level. मतलब क्या है, they occur at a small scale level. Okay, now in the case of Caesar fault, what is Caesar fault? Caesar faults are those in which there is an amount of rotation of the hanging wall takes place along an axis which is perpendicular in this case of hanging wall. Okay, so in the case given that in oceanic regions there are regional strike slip fault which is associated with the lithospheric plate boundaries, तो क्या होगा, ये क्या होगा, transform fault होगा, क्योंकि tear fault and ridge fault they are localized small scale faulting, they are also strike slip fault but they are localized और स्मॉल स्केल. सीजर फॉल्ट क्या होता है, ये एक स्ट्राइक स्लिप फॉल्ट नहीं होता, यहाँ पे जो फॉल्टिंग होता है द हिंज हैंगिंग वॉल इट इज़ रोटेटेड. ओके, so it is not a strike slip fault. So option A is correct for question number 43. Next we have question number 44. In question number 44 it is given that in a fold rock salt has broken through the more brittle overlying rock and occupied its core. The structure is called as disharmonic fold, drag fold, box fold or फिर diaphyl fold. Now see what is a disharmonic fold. A disharmonic fold is a fold in which the geometrical parameters like the wavelength, the shape of the fold, these changes abruptly within the folded layer. Okay, there is no continuity within the folded layer. Okay, this is called a disharmonic fold. Now in the case of a drag fold, the drag fold they generally are small scale folds that are present along the limbs of larger folds. Okay, and they are formed due to the dragging of incompetent layer by competent layer. Okay, इसके वजह से ड्रैग फोल्ड बनता है. जनरली लार्जर स्केल फोल्ड्स में व्हेन द limbs they are characterized by small scale folding, and these folds they have developed due to the dragging of the incompetent layer by the competent layer. Okay, when the competent layer they slide past over the incompetent layer, they drag the incompetent layer, and these types of small scale folds they occur. They are known as the drag fold. Box fold क्या होता है, they look like a box. Okay, here they have a long flat crest with two hinges on either side. These are called the box fold. And diaper fold क्या होता है, generally when there is a salt dome that starts to uprise from beneath a brittle layer, it will means break up the brittle layer. Okay, due to which the brittle layer will be folded with the salt dome at the center of the fold. Okay, this is called a diaper fold. अब क्या बोला गया है, in a fold rock salt that has broken through the more brittle overlying rocks and occupied its core. The structure is called as, फिर क्या होगा, disharmonic fold नहीं होगा, drag fold भी नहीं होगा, बॉक्स फोल्ड भी नहीं होगा, डायपिड फोल्ड होगा, क्योंकि यहाँ पे द सॉल्टी डोम लाइक स्ट्रक्चर इट ऑक्यूपाइज द सेंट्रल पार्ट ऑफ द फोल्ड, ओके, एंड देयर आर ब्रिटल लेयर्स ऑन आइदर साइड. सो आंसर डी इज करेक्ट फॉर क्वेश्चन नंबर 44. Now see what we have next is question number 45. 45 में दिया गया है कि a fault having both dip slip as well as strike slip component is termed as strike slip fault, dip slip fault, oblique slip fault या फिर ridge fault. Now what we have here, this picture, it is of a strike slip fault. Generally this bed, its strike is in this direction. इस बेड का जो स्ट्राइक है ये स्ट्राइक है उसका. तो जब स्ट्राइक के अलोंग द मूवमेंट ऑकर्स and the net slip is parallel to the strike of the bed, okay, if this is the strike of the bed and the beds are moving parallel to the strike, okay, then it is called a strike slip fault. In these faults there is no dip slip component. Dip क्या है, strike के perpendicular है. In this direction there is no movement, neither upward, it is always parallel to the strike. It is called a strike slip fault in which the dip slip component is 0. In case of dip slip fault, see this figure, here we have the strike and this is the dip, and along the dip the net slip has occurred, okay. net slip कहाँ पे हुआ है, dip के डायरेक्शन पे, okay. strike के डायरेक्शन पे कोई मूवमेंट नहीं है, ड्यू टू विच ये हैंगिंग वॉल है, ये फुट वॉल है. अब क्या होता है, हैंगिंग वॉल नीचे भी जा सकता है या फिर ऊपर भी जा सकता है, ये देखिए. अब क्योंकि ये मूवमेंट डिप के पैरेलल हुआ है, इट इज़ कॉल्ड अ डिप स्लिप फॉल्ट एंड इट डू नॉट हैव एनी स्ट्राइक कंपोनेंट. इट्स स्ट्राइक कंपोनेंट इज 0, ओके. ऑब्लिक स्लिप फॉल्ट, इन दिस केस, सी दिस केस, ऑब्लिक स्लिप फॉल्ट क्या होता है, दिस इज द स्ट्राइक एंड दिस इज द डिप डायरेक्शन, ओके. नाउ दिस डायरेक्शन the fault block has moved. This is the at a angle. This angle could be resolved in this part, that is parallel to the strike and parallel to the dip, okay. So we have both the strike component and dip component in the case of oblique slip fault, okay. Ridge fault, ridge fault क्या होता है, अभी हम देखे हैं that it is a strike slip fault, and in case of strike slip fault the dip slip component is 0. So in this case where we have both dip slip and strike slip component, क्या होगा, oblique slip fault. Option C is correct for question number 45. Given that a deep focused earthquake commonly originates along mid-ocean ridge, continental rift, transform fault and Benioff zone. Now in the case of the earthquake, a deep focused earthquake ये जनरली कहाँ पे originate करता है, mid ocean ridge. It is a long elevated linear structure which is present in the oceanic basin, okay. It is a long linear structure which is present in the oceanic basin, and along this the two plates, they are moving symmetrically apart from the ridge. This is called the mid ocean ridge or more. Generally the mid ocean ridge, they are characterized by transform faulting, and these faults, they are associated with shallow focused earthquake, okay. So mid ocean ridge are not associated with deep focused earthquake. This is not the answer. Continental rifts क्या होता है, generally when there is a brittle rock layer, okay, and a pluton, it rises up from beneath, प्लूटोनिक मास जब उठता है, मतलब नीचे से आता है फ्रॉम beneath the lithospheric plate, it results in lithospheric thinning. यहाँ पे lithospheric thinning हो जाता है, due to which with continued lithospheric thinning there will be breakage in this part and it will result in two lithospheric slab, okay. And these areas, they are not associated with deep focused earthquake because here the pluton, it has resulted in the rifting, and they mainly occur within the continents and they are known as continental rifts. So they are not associated with the deep focused earthquake, okay. In the case of transform fault, what are transform fault? Transform fault, they are present along the plate boundaries, okay, where the two plates, they slide past one another, okay, either up or down, okay. Like here you can see the offset, Now here the transform fault, as we have seen in the case of the mid-ocean ridge, the transform faults are present and they are associated with shallow focused earthquake. So transform fault answer नहीं होगा. Benioff zone क्या होता है? In the case of the Benioff zone, they are mainly associated with subduction, and when in case of subduction, one plate subducts beneath the other, like in the case of the oceanic plate subduct beneath the continental crust. So here what we get, the plates are subducting, due to which there is a great amount of collision at the subduction zone, and due to which deep focused earthquake originate in these regions. Okay, and Benioff zones are characterized by deep focused earthquake. So the answer will be D for question number 46. We have question number 47. In 47 it is given a major continent that existed before 90 million annum and comprised present day North America, Greenland, Europe and parts of Asia is referred to as, क्या बोलते हैं? Superior, Gondwana land, Laurentia, फिर Laurasia. देखिए, in the case of Gondwana land, it mainly consisted of South America, India, Australia and Antarctica. Okay. In the case of Laurentia, Laurentia जो था उसमें क्या क्या है? We have North America and Greenland. And in the case of Laurasia, Laurasia mainly consisted of North America, parts of Asia, Europe, Greenland. Okay. In this case, what we can see that the given statement, a major continent that existed before 90 million annum and comprised present day North America, Greenland, Europe and parts of Asia is, here we can see that in Laurasia we have North America, Greenland, Europe and parts of Asia. So answer D is correct for question number 47. Okay. Next question, we have question number 48. It is given that the rocks and sediments that were subducting sometimes get attached with overriding plate by thrusting. This process is commonly called as abduction, rejuvenation, underplating, offscrapping. क्या होगा? Now see, abduction in the case when there is an overriding plate and another plate, it is subducting. Okay. Now in this case, generally the plate that is subducting, its sediments, they are scraped off from the top of the plate and they are thrusted onto the overriding plate. Okay, generally abduction is found in case when the oceanic plate is subducting and a parts of oceanic plate is abducted or thrusted onto the continental plate. Okay, in the case this is continental plate, this is oceanic plate, this is called as abduction. Now in case of rejuvenation, rejuvenation is when there is elevation of landmass occur when the landmass they increase in their height. So the earth will try to equilibrate the elevated landmass by eroding it. So erosion takes place and this process is called rejuvenation. Underplating क्या होता है? जब when the subducting plate, okay, is subducting below the overriding plate, then the parts of subducting plate, it is added to the lower part of the overriding plate and this is called as underplating. Offscrapping is when the sediments of the overriding plate, they are scraped off and this is the subduction zone, they form thrust sheet here. Okay, then it is known as offscrapping. Generally these thrust sheet that develop in the subduction zone, they are known as the accretionary prism. Okay, so in the given question what we have is the rock and sediment that were subducting sometimes get attached with the overriding plate by thrusting. अब देखिए यहाँ पे क्या दिया गया है, जो स्टेटमेंट है वो it is not clear that what it is trying to say, whether the oceanic plate is thrusted onto the continental plate तब abduction होता या फिर parts of the plate is underplated over the overriding plate, then it would be underplating. या फिर by which accretionary prism has formed means the sediments they have scraped off from the top of the subducting plate and they are thrusted onto the overriding plate in form of thrust sheet by which the accretionary prism develop. इसको बोलते हैं ऑफ स्क्रैपिंग. अब ये जो है ये क्लियर नहीं दिया गया है. सो अकॉर्डिंग टू मी ए सी डी कोई भी एक आंसर हो सकता है. ओके, नाउ नेक्स्ट वी हैव 49. द लिथोस्फीयर इज कंपोज्ड ऑफ व्हाट. यहाँ पे लिथोस्फीयर बोला गया है, किससे बनता है? मैंटल या फिर आउटर कोर? मैंटल एस्थिनोस्फीयर, अपर मैंटल एंड क्रस्ट, कॉन्टिनेंटल and oceanic crust. Okay, so what we have here is the division of the layers of the earth. We have the upper crust, then the mantle, outer core which is liquid, and the solid inner core made up of nickel and iron alloy knife. Now in this case what we have is the lithosphere. Lithosphere, as you can see here, this part it represents the lithosphere, and this part it is the crust, and this deep brown part, this part it is the upper mantle. Okay, so in the case of lithosphere, the crust and the upper mantle makes up the lithosphere. So option upper mantle and crust, it makes up the lithosphere. Option C is correct for question number 49. Okay, what we have is question number 50. It is given that in the case of hexagonal crystal, there is one and only one direction which shows no double refraction, and this direction is called optic axis, optic axial plane, isogyre, optic normal. Now in the case of the hexagonal crystals, they are uniaxial in nature. Okay, uniaxial means they have only one optic axis, and optic axis is, in the case of the hexagonal crystal, the optic axis is the direction along which there is no double refraction. Okay, in case of optic axis, it is the direction along which there is no double refraction. So it is given that in the case of hexagonal crystal, there is only one and only one direction along which there is no double refraction. So optic axis is that direction. Now दूसरे भी देख लेते हैं, optic axial plane. In case of biaxial crystal, that is they have two optic axes, and the plane that consists of these two optic axes is called the optic axial plane. Okay, and the normal to this plane is known as optic normal. Okay, so optic axial plane and optic normal, these are not the answers, because along which the double refraction phenomena which is given here, it is not means correct. And isogyre, in the case of the uniaxial mineral, these bands, along these bands, these are called the isogyres. Okay, these are called the isogyres. In the case of isogyres, why they are called isogyres? Because they are bands of equal retardation. Okay, equal retardation. Now isogyres समझ में आ गया. So in the case of question number 50, optic axis is the direction along which there is no double refraction. So A is the answer for question number 50. Okay, so the next question is question number 51. Here it is given that the interference figure produced by a uniaxial crystal cut parallel to its optic axis is known as, in this case the options are dichroic figure, flash figure, Brewster's figure, and uniaxial indicatrix. In the case of dichroic figure, the property of dichroism is shown. This is when a mineral, it absorbs the light in one direction more as compared to the other. So there are two different colors. यहाँ पे एक color मिलेगा in this direction, and there will be another color produced in this direction. Two different colors in two different direction. Okay, in those minerals. Okay, that is called a dichroism, and generally dichroic figure shows the property of dichroism. Now, in the case of flash figure क्या होता है? Generally, it is found within the uniaxial mineral. It is found within uniaxial mineral where the interference figure that is produced by the uniaxial mineral, it when cut parallel to its optic axis, it generates a flash figure. Okay, the flash figure, they are also known as the optic normal figure, and also that here the optic axis which is parallel to the stage of the microscope. Now, in the case of the Brewster's figure, there is a law of Brewster's that gives us that the refractive index of an unpolarized light of known wavelength can be determined. Okay, the refractive index of an unpolarized light can be determined when its wavelength is known, which is the Brewster's law. This law is generally used in case of polarized sunglasses, so that the glares that come from the sun, जो सूरज से जो भी रोशनी हमारे आंखों पे पड़ती है वो हम डायरेक्टली सूरज की तरफ नहीं देख पाते. For that we use polarized sunglasses which can protect us from the glares of the sun. Okay, and this polarized sunglasses, they use the Brewster's law for that purpose. Okay, now in the case of the uniaxial indicatrix, देखिए indicatrix figure जो है क्या दिखाता है, that is the relationship between the refractive index and direction. Okay, that is the refractive index. It varies with direction in the case of crystal, and the relationship of refractive index with direction, when it is represented geometrically, the figure so obtained is called an indicatrix, and in case of uniaxial mineral it is called an uniaxial indicatrix. In case of uniaxial mineral we generally get a ellipsoid with one circular section. Okay, this is called an uniaxial indicatrix. Okay, now in the case of the interference figure which is produced by uniaxial mineral cut parallel to its optic axis, it will be the flash figure, because in case of flash figure, it is found within the uniaxial mineral, and it is the interference figure. It is generated when the optic axis is present parallel to the stage of the microscope, means here when the crystal will be cut, it will be cut parallel to the optic axis. So the answer will be flash figure for 51B. Next question 52. Which one of the following instrument can be used to distinguish kyanite, sillimanite and andalusite? देखिए, in the case of kyanite, sillimanite and andalusite, what we have, they are the Al2SiO5 polymorphs. Okay. अब क्या है, kyanite जो है वो क्या है, ट्राइक्लिनिक, and andalusite and sillimanite, they are orthorhombic. Okay, their crystal system orthorhombic. Now here what we have in the option is the EPMA method. EPMA method, it is known as the electron probe microanalysis. Okay, electron probe microanalysis method. This method is mainly used for determining the chemical composition of materials. The XRD method, X-ray diffraction method, it is used to determine the crystal structure. Then the XRF method, X-ray fluorescent method, that is generally it is used for the iron ores. And the ICP-MS, the inductively coupled plasma spectroscopy. The inductively coupled plasma spectroscopy, it is used to measure the element at trace level in biological fluid. Those elements that are present in trace level, that is trace level, they are used, we use ICP-MS method to determine them. अब क्या दिया गया है? Which one of the following instrument can be used to distinguish kyanites, limonite and andesite? Okay. Now, the kyanites, limonite and andesite, they are polymorphs of A2SiO5, so they have the same chemical composition. Chemical composition के ऊपर base करके we cannot find which one is kyanites, limonite or andesite. So EPMA method use नहीं होगा. XRD by crystal structure यहाँ पे determine होता है. So the kyanite is triclinic, andesite limonite orthorhombic. यहाँ से हम लोग जान सकते हैं कि कौन सा मिनरल kyanite है, कौन सा limonite और andesite. Okay. Now in the case of X-ray fluorescence method, it is mainly used for iron ore. Aluminium silicate के लिए use नहीं होता, तो ये भी नहीं होगा. और जो ICP-MS method है, ये generally used to determine the elements that are present in trace level within biological fluid. So this method is not also used. So answer for 52 is XRD B. Okay. Next question 53. Match list 1 and list 2 and select the correct answer using the code given below in list 1 and list 2. Okay. List 1 is mineral example, list 2 is silicate classes. Okay, so in the case of first we have phlogopite, enstatite, anthophylite and beryl. In list 2 the silicate classes are ironosilicate single chain, cyclosilicate, phyllosilicate, ironosilicate double chain. अब देखिए in the case of phlogopite, phlogopite क्या है? एक mica mineral है. Okay, enstatite क्या है? एक pyroxene है. Anthophylite, it is an amphibole and beryl. Okay, so in the case of mica mineral जो होता है वो phyllosilicate होता है. So phlogopite, it is a phyllosilicate. Okay, so A is 3 and then B is enstatite. Enstatite जो होता है एक pyroxene है and pyroxene they are ironosilicate and single chain ironosilicate. Okay, then B is 1. Anthophylite amphibole. Amphibole is also ironosilicate, but it is not single chain, it is double chain ironosilicate. Okay, so C is 4. And beryl they are cyclosilicates, so beryl is 2. So we have 3 1 4 2 order. What we have here is 3 1 4 2. Option A is correct for question number 53. Number 54, what we have is muscovite belongs to which one of the following types of phyllosilicate structure. So muscovite क्या होता है? ये एक mica है, mica mineral, and it is a phyllosilicate. That is, it is having a sheet silicate structure. Okay, it have a sheet-like silicate structure. And here in the case of muscovite क्या होता है? ये जो sheet like silicate का structure होता है, these sheets they are made up of 2 TOT layers. ये जो होते हैं these TOT layers, that is the tetrahedral, octahedral, tetrahedral, this sheet layer they are separated by an interlayered cation. Okay, they are separated by interlayered cation and they are dioctahedral. Okay, TOT layers. Now in this case what we have, the options are dioctahedral TOT, interlayered cation, dioctahedral TOT. Dioctahedral TOT type only, trioctahedral TOT, interlayered cation, trioctahedral TOT type, or dioctahedral TOT type only. Now in the what we have is a dioctahedral TOT layer. It is separated from another dioctahedral TOT layer by an interlayered cation. So option A it matches, other are not the options. Okay, so for 54 option A is correct. So the next question we have is 55. Given that which one of the following expressions is correct as per notation of Miller indices of a crystal phase? Okay, now in the case of Miller indices क्या होता है? Generally हम अगर पकड़ ले कि 1A, 1B and 1C, these are the intercepts. That is, A axis is intercepted at unit distance, B axis at 1 unit and CSIR at 1 unit. These are the axial ratios. So to find the mirror indices of this given axial ratio क्या होता है? First हम लोग 1 1 1 we will take this, then second reciprocal लेंगे, third we will take the LCM of the numerator, वो तो 1 ही है, and we will multiply it with the, we will take the LCM of the denominator, sorry, numerator नहीं, denominator, and we will multiply with the numerator. And फोर्थ क्या होता है यहाँ पे? So we have 1 1 1, ठीक है? This is the mirror indices and within a bracket that represents a face. So here what we have, A is the answer, because जो ratio में होते हैं fractions, वो तो mirror indices, they do not show mirror indices. 1A 1B 1C, they are the actual ratios, that is at what distance the axes are intercepted. Okay, it is not the answer, or 1 1 1, it do not represents a crystal face. Okay, so 55A, it is the answer. Okay, next question is question number 56. Given that the exsolution texture in which the host mineral is a plagioclase feldspar and the lamellae are of KAlSi3O8 composition is known as perthite, antiperthite, myrmekite and inverted pigeonite. Now, in the case of perthite जो texture होता है, generally in this the host is rich in K feldspar and the lamellae, they are rich in Na plagioclase, sodic plagioclase. Antiperthite, that is the host, they are rich in sodic plagioclase, and the lamellae, they are rich in K feldspar. Okay. Now, in the case of myrmekite क्या होता है? Generally within a plagioclase, when we get blebs of wormy quartz and we have an adjacent orthoclase feldspar, we generally call this texture as myrmekite. मतलब ये जो blebs है quartz के, ये plagioclase के अंदर पाए जाते हैं, and the plagioclase has an adjacent is adjacently present to the orthoclase feldspar. It is called myrmekite texture. Inverted pigeonite क्या होता है? This is a high temperature, low Ca bearing clinopyroxene. Okay, it is called as pigeonite, inverted pigeonite. Now, as we can see that the exsolution texture is represented by a host mineral of plagioclase feldspar and a lamellae which is rich in orthoclase. क्या होगा? अगर host यहाँ पे plagioclase rich है and lamellae K feldspar rich है, तो क्या होगा? Antiperthite. Okay, 56 option B will be correct. Okay. Next 57 question number. It is given that match list 1 with list 2 and select the correct answer using the code given below in list. Okay, in list 1 we have the mineral name. In list 2 we have the mineral classification. So what we have is sylvite, manganite, siderite, monazite. Classification carbonate, phosphate, hydroxide and halide. अब क्या है, ये जो मिनरल दिए गए हैं सिल्वाइट, सिल्वाइट क्या है? Composition KCl, it is a halide. Okay. Now manganite, manganite is MnOH, it is a hydroxide. Okay. Now we have the third siderite, that is FeCO3, that is a carbonate. और फोर्थ क्या है? मोनाजाइट. मोनाजाइट क्या है? ये फॉस्फेट होगा. ओके, 3 पता है, फोर्थ विल बी द रिमेनिंग. ओके, नाउ इन दिस केस what we have, sylvite, that is A, it will be a halide, that is 4, B, manganite, a hydroxide 3, C, siderite, a carbonate 1, and D will be phosphate 2. 4, 3, 1, 2. Where is the answer? D. Answer D is correct for question number 57. Okay. Next question what we have is question number 58. What it is given that labradorescence observed in plagioclase is caused by polymorphism, presence of closely spaced lamellae of anorthite 0 to 25 composition, or fine exolution lamellae of anorthite 47 to anorthite 58 composition, or peristerite gap. Now see, what do you mean by labradorescence? Labradorescence, this is a property which is shown by labradorite. It shows an iridescent optical property, okay, and this is called the labradorescent. Now in the case of labradorite is a member of the solid solution series of albite anorthite. Okay, it generally plots at a percentage anorthite content of 50 to 70. Okay. Now, in the given options we have polymorphism. Polymorphism क्या होता है? जब chemical composition same होगा, but crystal structure जो होगा वो different होगा, उसे हम polymorphism कहते हैं. जैसे Al2SiO5 के क्षेत्र में हम लोग क्या देखते हैं? Al2SiO5, the chemical composition is same, but we have different minerals with different crystal structure. That is kyanite, andalusite, sillimanite, and they do not show any type of iridescent effect and like labradorescent. So first option होगा नहीं. Now in the case of the presence of closely spaced lamellae of anorthite 0 to 25 composition, we can see that labradorite, it has a percent anorthite content of 50 to 78. So 0 to 25% anorthite content, यहाँ पे तो labradorescent property show नहीं होगा. So B is not the answer. Then we have fine exolution lamellae of anorthite 47 to 58 composition. Now 47 to 58 जो composition आ रहा है वो 50 to 70 के बीच में आ रहा है. Now this is the answer. Here we find labradorite, and these lamellae generally shows labradorescence property. Peristerite gap. Peristerite gap क्या है? It represents an equilibrium between the ordered low albite phase and disordered high albite phase. Okay, the peristerite gap, it is because of the equilibrium between the ordered low albite phase and the disordered high albite phase. The ordered low albite phase, they are generally pure NaAlSi3O8 composition, and the disordered high albite phase, they have an higher amount of anorthite content. They are anorthite rich. This equilibrium, it represents a peristerite gap. Okay, so this is not the correct answer. So the correct answer is 50 for question number. So the correct answer is C for question number 58. Okay. Next question is question number 59. What we have is match the Hermann-Morgwin notation of list 1 with list 2 and select the correct answer using the code given below. List 1 we have the symmetry content and list 2 the crystal classes. Now what symmetry content we have is 3A4, 4A3, 6A2. Here what we have is 3A4, 4A3 and 6A2. पहले ये देख लेते हैं, ठीक है. यहाँ पे A4 मतलब the tetrad axis, A3 मतलब the triad axis, A2 means the triad axis. Now the number of axes they are represented by this prefix. यहाँ पे 3 tetrad axis है, 4 triad axis है and 6 diad axis है. ये कौन सा crystal class represent करते हैं? This represents the 432. Okay, it represents the 432 crystal class and it belongs to the cubic system. ठीक है. Second क्या है? We have 1A4 and 4A2. Here what we have is 1 tetrad axis and 4 diad axis. These diad axes could be divided into 2 and 2. So what crystal class we have is 422. Okay, and this is of the tetragonal system. Now Third, 1A2 and 2M. In 1A2 and 2M we have one diode axis and two mirror plane. ये किस क्लास को रिप्रेजेंट करते हैं? दैट इज MM2 और ये किस क्रिस्टल सिस्टम में पाए जाते हैं? दैट इज ऑर्थोरोम्बिक. Okay, now last we have 1A6 and 6A2. Again, one hexad axis and 6 diode axis. They could be divided into two equal part of 3 diode axis and 3 diode axis. That is 6 to 2. That is belonging to the hexagonal system. So अभी मिला लेते हैं कि A का क्या होगा? 3A4, 4A3, 6A2. That is we have 4, 3, 2. Okay, that is 2. Then 1A4, 4A2. That is 4, 2, 2, 1. Then 1A2, 2M, M22, 3. 1A6, 6A2, 6, 2, 2. That is 4. We have 2, 1, 3 and 4. Okay, what we have? Option A. 2, 1, 3 and 4. Option A is correct for question number 59. Okay. So आज का जो लास्ट क्वेश्चन है वो है क्वेश्चन नंबर 60. देख लेते हैं क्या है. In each crystal class there is a form the face of which intersect all the crystallographic axes at different lengths. This form is known as special form, general form, open form or closed form. Now what we see here is the special form. What is a special form? A special form is one in which the crystal faces, here the crystal faces are parallel to one or more crystallographic axes. In the case of general form, here the crystal faces intersects all axes at different lengths. Okay, in the case of closed and open form, now see, in the case of a open form होता है when the crystal faces they do not enclose a complete space between them. It is called an open form. And as the crystal faces they are not enclosing a complete space between them, so क्या होता है? ये all the crystallographic axes के साथ intersect नहीं करेंगे. Okay, in the case of closed form, here the crystal faces they encloses a well defined space, okay, between them. And here also the crystal faces they do not intersect all the crystallographic axes. Okay, now here as it is said that in each crystal class there is a form that the faces of which intersect all the crystallographic axes at different lengths. So we can see that general form is a form the crystal faces of which intersect all the crystallographic axes at different length. So the answer will be B, general form. Okay. As we have completed the solution video of question number 31 to 60, the remaining questions that are present will be uploaded with their solutions in the YouTube channel of Academy of Earth Sciences. Please follow our YouTube channel to get the regular updates, and please feel free to like, share and subscribe. Thank you everyone.